Yes. Yes. Perfect.
Good. So the first step, you can go to the website of the workshop, and here in the panel on the left, you have a page called Hands-on Demo Manual. And here you can find all the steps of the demonstration that we are going to give. And so you can follow step by step, just copy and paste if you want the commands from your side, and we will be able to follow the demonstration if you want to participate actively to this demonstration and get an overview of the tools. So it's free for you to just look at the demonstration or test these tools from your side. First step of this demonstration, we will take a look at the source code, and for this we will go to the GitHub organization. There is a link at the top of this page. You can go for this website and take a look. Guillermo, can you?
Yeah. So this GitHub organization contains all the different repositories for each of the different data challenges, and also some general repos for DC tools, which is our main functionality library, which centralizes all the different tools, data loading tools, data preparation tools that we use in the others, and also the evaluation tools. The metrics themselves are not in this repo here, but we do call the Ocean Bench library that we forked from Mercator Océan to calculate the metrics and then prepare like the different results, which we then put in the leaderboard. So yeah, first we have DC Leaderboard, which is just a tool for creating the web pages where we show the different results. Right now, we have to manually add the results to this repo to have them in the website, I think. So, and then we have a repo for each of the different data challenges. So for example, if I hop on the third data challenges repo, we see just for now the README is very basic, but we're going to add more standardized documentation afterwards. And the main thing that you will be interested in as a participant to any of the data challenges will be a little config file that's just here. So in these files is where you will be able to configure absolutely everything you need about data challenge without getting into the specifics of the code. So that will allow you a level of abstraction that will simplify your life, we hope, quite a bit. So since currently we have our pre-processed data in private S3 storage in Wasabi, we do need to provide certain access keys. So we created a read-only user with the credentials already in the GitHub. So until we manage to move all the pre-processed data to Datamor, we will have to make do with this. But bear in mind that our tools do take into consideration that the data can come from many different sources. So even if you have some other type of S3 storage, you could totally use it to submit some kind of model or participation to the data challenges. Then if we move to the general parameters, the data challenge library will first of all read everything that's on the storage that you have specified below, which I will get into a bit. And it is very versatile in how it can assign different measurements to calculate different metrics. What I mean by that is, for example, we can use the whole of Nadir satellite measurements, for example, for SSH, for a single day, or we can just take smaller time steps for which we aggregate all the measurements that we have there and then use those measurements to calculate class 4 metrics. We can also do very different types of forecasts with this. For example, in the case of TC1 for GlowNet, we have a 10 days forecast every week. So in that case, we would just put 7 and 10 here, and we would be able to evaluate the short-term capability of a model over a whole year, for example, or whatever period we want. And in this case, since we're doing seasonal forecasting, we're just evaluating over the whole winter period once per year, because there's just one winter per year, you know. But all of this is very modular. You can adapt this to your machine and to your computing power. Here we just provide some basic settings that will work for most computers, we think, but you can totally adapt this to make this run faster and take advantage of whatever computing resources you might have access to. And we also provide data filtering configuration options, just in case you want to focus on a specific region or a specific period. In our case, we're doing, for this data challenge, global Arctic, an evaluation over the whole Arctic. So we're not really touching the limits of the X and Y coordinates that we're looking at. But for example, if you're looking at one of the first 2 data challenges, which are supposed to be evaluated on a global timescale, you could also use these tools to evaluate on specific regions, like the Mediterranean or the North Atlantic or whatever you might be interested in. And finally, for the different data sets, we really have to underline the fact that these tools are very modular, so you can really put whatever kind of data you have into a data challenge, and we hope that it will be able to take it in stride. For example, here we just define a bunch of data sets that we have in our private storage in Wasabi, but this could also work for FTP data sets that you might have, or just local netCDF files. And the reason for this is that some of the predictions that the participants are going to make are just so huge that they will not be able to fit in local storage. So we really wanted to be able to put the predictions on a server and from there calculate the metrics directly and minimize the amount of server requests and downloads and local space that we have to use. We even provide filtering for different variables, because some of the model predictions just predict a bunch of things that we may not be interested for the data challenges. And it also has the advantage of being very robust to different naming conventions. That's been quite a pain for us to deal with the different ways that different institutions name their variables. For example, sea ice concentration in AMSA 2 is called Z, which is not very descriptive. While some other places use sea ice concentration, the full name, or just CI conc. All of that you can just not worry about. You just put the name of your variable and it will automatically try to convert it into the standard names that we use in the library to provide, hopefully, correct evaluation. Same thing for the IABP data set, which is a bunch of in situ measurements. We haven't tested it yet in this DC in particular, but I think it is the case for Argo floats as well, that you can calculate metrics on the observation space like we do for class 4 metrics. And you don't have to worry about interpolating your data set to the actual points of the measurements. That's all taken care of by the library, and it takes full advantage of all the Dask parallelism magic that we all know and love. So yeah, pretty much the same thing for MODIS here, where we just loaded the data set and the different variables that we're interested in. And finally, if you want to participate in a data challenge, you would just add your own predictions as another data set. So for example, here we're using Topaz as a baseline. So we just set it as not an observation data set, since it's actually our predictions. We just specify where we can find it. It could either be S3 storage, FTP, whatever you want. And then we specify which variables we want. Topaz actually predicts a bunch of CS variables, and here we're just looking at CS concentration. And you will see that we actually use a different name, but when we run the evaluation later, you're going to see that it's automatically taken care of, and it will provide actual evaluation metrics for that. So that's pretty much the whole of the config file.
As an addition, Guillermo, I will say that this is modifying this config file. That dataset part is necessitate to have some knowledge about the data itself. So it can be quite complicated if you don't know how to do it. The final state of the data challenge, this file will not be modified, has to not be modified. We'll make an interface in the code for to download the data coming from the participant. This will be made outside of this configuration file. So what we are saying is that if you want to test, just make a test on your system, you can modify the parameters that are in these config files to reduce the scope and see if this everything is working. At the final state of these data challenges in the version 1, we will make an interface that will make the ingestion of your data sets for you. So you don't have to touch these config files that will be freezed at the end. So the data challenges is fair for all participants. I wanted to clarify this.
Thank you, Kamel. We're also planning on adding the documentation, read the docs very soon for each of the data challenges, just to make it very easy for anyone to go into the repo and realize how they have to set up their environment, which is a bit tricky due to some external bugs. Hopefully with the Docker images, that will all be taken care of, and you won't have to worry too much about dependency health. And we also want to provide some example notebooks that anyone can just look at and see just some sample evaluation, so they can get inspired when they want to run their actual evals. I don't know if there's anything else to mention about this.
Yeah, about the organization. In GitHub, there are more repositories. There's one about the information on the data challenges,
yeah,
which is of interest.
Yeah, so if there is nothing else to go over in the specific data challenges, we do have another repo that we call very creatively data challenges info, where we're gonna share some information, like for example, different postdoc proposals I think are there, or the proposals for data challenges. We hope to centralize all the information there. And yeah, you will have all the links related to the Préparation Climat there, and we're probably going to put the slides and the recording, at least a link to them, in this repo, just in case some people who aren't here are interested in knowing what we discussed and what the data challenges are up to.
And yeah, in each one of the directories in this repo, you got specific information about, there's a PDF detailing the scientific background of each data challenge.
Yeah. There's this, there is here. And also we have made some quick summaries about each of the data challenges with some references, and also what the proposing team had in mind when they propose the data challenges, a bit of context, some links to the data sets, which may not be treated, but we will have the treated versions in DataMof very soon, we hope. And for example, in this DC1, you have like the evaluation data and different metrics they want to use, as well as links to all the baselines, which might be very interesting if you want to get inspired and submit your own participation.
There are other repos in this organization.
Yeah.
There is one containing Docker images that can be used to deploy pre-configured environment that will simplify the use of these data challenges, so you don't have to install the manually install these environments. And there is also the repository that creates the leaderboard HTML page. So you can show this one.
Yeah.
Yeah, we'll make a demonstration of this later in this demonstration.
So anything else you would like to mention, maybe about DC tools? A quick word on that.
DC tools. It's the main repository with which has the almost all the code that we created. So this is it backups the data challenges, the 5 data challenges repositories we have, which have very few code inside. There is only calls to the tools that are implemented in this one. Somebody that wants to participate to a data challenge does not have to care about this this library. It's just a dependency of the data challenges libraries. So this is interesting to only in the way that it gives the tools for the data challenges repositories to create the full pipeline for the evaluation.
I think we've...
Yeah, the last tool, which is OceanBench, is not in the this organization. It's the repo that computes the metrics, but it's a fork from the Mercator tool. We don't host it in this this organization. Hosted outside. I think that's all that we can say about this code. Do you have any question at this step? Or yeah, we can move to the
actual
demo itself.
Okay. Well, let Kamel get started with that.
Yeah. So, as I said before, you can go to this page in order to follow to get the full set of commands that we will use now to demonstrate the our software. So we can start here at the step 2, run the evaluation. And here we will show the different ways to run these data challenges, starting from running in the local machine by first creating the proper environment. But this is done by first installing the environment. And then once it is installed, you can go for running the evaluation. And then as a second step, we will give the more simpler ways to do this. First, by using the services that we deployed on the Editor Data Lab platform. We put here the links, that you can use to access these services, and we will show how to use them to run an evaluation. And the last way to start our data challenges benchmark is to use Docker images that have also the same advantage that than the Editor Data Lab, is that you can get a fully ready-to-use environment. So you just have then to run the buffer command to get the evaluation running. After that, when we got our results file that is the output of this evaluation step, we will switch to creating the leaderboard, so the tables that summarizes the results that we got. And we will demonstrate how to make this later. So as a first step, we will try to run a local evaluation on the local machine. So you can open a terminal or an IDE as you wish to make this. So as a first step, let's create a folder where we will put the code. And at this step, the first thing to do is to download the code from from GitHub. And as I said before, you can just copy and paste the commands that are here. And for you to know, there are only the 3 first data challenges that are working now, as we said this morning. So you can use the data challenge 1 or 3. So data challenge 1 for physical variables evaluation, or data challenge 3 for sea ice variables prediction. The DC2 is something like the DC1, but there is more data and it will take more time to run, and because the software will download the data online when you evaluate, and this will take much more time than running the DC1, because in this room the Wi-Fi connection is somewhat slow. So it's better to try data challenge number 1. Okay, so let's download the data from GitHub. Once it's done, you switch to the directory where the source code is installed. And now let's start creating the environment. So the first step, sorry, this is a demo that is Linux friendly, but we didn't test on other operating systems. So maybe the commands here are not the proper one if you want to test on Windows or Mac. But let's go for this this installation. First thing is to install Poetry, which will manage all the dependencies. We work this way to manage all the dependencies of our software. So we use Poetry tools to make this. So if you don't have Poetry installed on your system, there is the way to go. So we put there a list of commands that you can use on your terminal or IDE to install this this tool to manage these dependencies. It's already installed on my local machine, so I won't go on these steps. I will switch to creating the Conda environment that we will use to run the. So I have to recreate this environment. And this is the step that I missed. So yeah. If you don't install these libraries, it won't work. I'm going fast on these steps because I already explained them, but if you miss one of them, the software won't work. So now I'm installing with Poetry, reinstalling. Okay. And once dependencies are installed, we can run a test, and fortunately, it will work. So now the evaluation is running, and it will go through several steps. And the first one is to check data sources and download the data online. And here we have several sources of data. So it's going first checking the sources and preprocessing, and then we will have the evaluation step. It will call the OceanBench library to compute the metrics. So depending, as I said, on the network speed, it can take can be very fast or take a long time. But here we calibrated the data, the test to little scope in order to have it running fast. So and what it's doing now is that we got 2 forecasts separated by a period of a week, and these forecasts will have only 2 days. So it's a very small example, just to demonstrate how this data challenge works. So this is what the logs are showing. We are processing the 3rd of January 2024 and the 10th of January of the same year. And this is for these forecast dates, we have the output coming from GLONET model, so we can got results as I said. For now, we just have the baselines. There is no result from the competing model. So we got results from GLONET, and then to show a leaderboard with color code comparison, we will generate fake model results using the tool that we showed before, which is DC leaderboard, and this is coming in a further step. So data is processing. So what it's showing now is that it's processing the data sources one by one. So we are evaluating on GLONET, and first data source that we have evaluated is satellite JSON3, and then SARAL is finished also now. Third one is also a satellite, a SWOT satellite, and the last source that will be evaluated is coming from GLORIS 12 as a reference data. Compare the GLONET results on. We also had Argo profiles, but as I said this morning, the server is down these days, so we won't evaluate for this demonstration on it.
Just to check in the room, everyone managed to install the content environment properly, or is anyone having, I see some faces telling me there's some problems, but.
Yeah, we tested here, and in our office, it's much more faster than here. Connection is very slow. Okay, now it started evaluating on the last data set, which is GLORIS 12, and fortunately it will not. Yeah, it's the biggest data set, so it will take some time.
And I think something that is nice to clarify about what's going on here is that for SARAL or SWOT, it's actually class 4 metrics, right?
Yes.
So we are interpolating directly in the observation space without having to specify where those points are. It will just automatically look it up, interpolate there, and calculate the corresponding metric. Whereas for Gloris, it's actually a gridded data set, so the interpolation process is quite different.
There is a previous step, which is formatting because to compare two gridded data set, they must be on the same grids. So there is a we made this offline because it's a long process. So we have a tool in provided in DC tools that will make this for you. Interpolate gridded data on the proper grid to compare to our baseline. So this has been done for Gloris as it is a reference dataset. We done it offline and we stored in our bucket this data because it's to make this on a big dataset like this. It takes very long time. So this is done once and for all for this reference data, and we store the resulting result. Because Gloris is high resolution dataset, so we subsample it to go to the proper resolution on quarter degree. And then we also interpolate it to get the same spatial position in the grid as GLONet. And now as you see, the evaluation has finished. And this message says that we have the results that are saved in this this folder. So it's finished. And we will see after that, in the demonstration, maybe this afternoon, how to use the files that have been generated with this tool, and how to create tables and leaderboards in order to visualize the result. So we will look at this. This directory, and in results inside this directory, you see that it has generated results glonet.json file, and in this file you can look at it. This is the file, and for each of the dates that were evaluated, you will see an entry with the metrics that was computed for each of the reference data sets that we showed. First one is Gloris, but we got also the observation data from Saral. This is this one, and SWOT, and the last one, JSON 3. So this is the format that we have, and we the evaluation is done on a fine-grained manner in the grid that we define. But here we see only the global result. That is the averaging all the spatial position that we are evaluating on. But we got we can save the intermediate results, and this will be done afterwards. In the final result, the final version of the data challenge, we will take all the spatial beans for which we have evaluated, and we will put this on a map to visualize the results in a fine-grained manner. So how to use this, as I said, this result file, we will see this afternoon how to generate the leaderboard. And for now, we'll switch on a more friendly way to run the data challenge. Now we got a really hands-on demo, but now we can use, as I said, the service that we deployed on the platform the Edito Data Lab platform. That is the recommended platform for a lot of services for ocean modeling as the service that we are implementing. So if you want to deploy data service for Data Challenge 1, here you have the link to open and look for the service. Or you can also test the service that we deployed for Data Challenge 3, the CIS forecasting. And you also got this link to open. So let's go for Data Challenge 1. Copy the link in your browser, and you will get into the service that we deployed here. For those who already have an account on Edito, we have sent a message for all the participants that have subscribed to the workshop to open an account in this platform. So if you already have an account, you can connect to the service and then use the link in the description of the demonstration to get inside the service. Otherwise, you can find it by searching in the services list of the platform. So you can just try a keyword like emulating global ocean to find this DC1 data challenge. So once you got inside this page with the link that we provided, you go here and you run the service with this button, lancer. And we will wait some time. As I said, we are always depending on the network speed, because now it's charging a Docker image inside Data Lab. And once we got the service and this image deployed, we can start testing the data challenge. But now we have to wait till this Docker image is downloaded. It's downloading, as I said, from the GitHub repo that we showed before, where it is named DC images, if I'm not wrong. So it's downloading from GitHub this image. So running this Docker command will download the Docker image from the net, and it's quite heavy. So it's better to start it now. Let's see if it will be ready for the demonstration. For those that don't have Docker desktop installed on their system, I have put here a tutorial on how to make this, how to install this software. You won't run Docker commands without this software installed. So you can just copy and paste this command, and don't use the DC3 Docker image because it has import problem. We have to fix it before. So you can test with the Docker image of the data challenge number 1. So let's open a terminal and run this this command. If the this command was already run on a terminal. You don't have to wait for the image to download. It's stored on your system. So I already downloaded it. So when I run a second time this Docker command, it will bring immediately the system. But when you run this for the first time, the Docker image that you give as an argument for Docker will be downloaded, and it's an image of several gigabytes, so it's somewhat long to download. So if you can run this command now, and hopefully it will be ready for the demonstration after we finish with the editor service. So this morning it was not working, but we found a way to make it run. So let's get the link to the editor service here. For Data Challenge 1, it's this link. And we copy this on a browser. Okay, this time, rather than launch it immediately, we will go here in this menu and choose editor the text editor here, and we'll change a parameter because now it was blocked by the waiting for a GPU to be ready. It seems that there are no GPUs available now on the platform. So we will put this parameter here, nvidia.com GPU. It was set to 1, we'll set it to 0. So we won't ask for a GPU and we won't wait for it. Why? Okay. Let's launch it now. Oh, okay. So it's quite fast this way to get the service running. So next step is to click here to get the password for the service, and then just click here to open it. And the password that we just copied now will paste it here, password or token, and we'll click on login to get inside the service. So here we are, and it's something like a little operating system that we got here, minimalist, with just the software needed to run our service that is pre-installed. We don't have anything to do. If we had set a notebook, we could use it, but we still don't have a notebook running on this service. So we will just open a terminal, and here we will launch the script that will run the data challenge. So I just have to call the Python script in DC1 evaluate.py, and this way we'll get the service running, and it will take into account, here we have the same code as in the data challenge repo that we showed before, and it will run now with the configuration that is listed here in this configuration file that we showed also before this morning. So let's run the script. And as I showed this morning, it will go through the same steps as the demonstration we made this morning using this Python script locally on our machine. So the script is running, and as we saw this morning, it's downloading the data and processing each of the dates that we have set in the config file. And now the evaluation will start, and it will save the result as we saw this morning also here in the root directory. He created, this is pre-configured, so in the service it will create a folder here, and inside you will find a results directory, and when the evaluation is finished it will put the file with the results here in this directory. As you see, it's a bit faster than the demo we made this morning. It's because the evaluation is running now on this server side in the Edito platform. So it ran much faster than what we saw this morning when we ran it locally. And now the evaluation is finished. And as you see in the folder that I opened before, a file appeared with a, can check inside. So the same format as this morning, and you see that the metrics computed are stored in this file for each of the dates and different reference datasets that we configured in the config file. So we are done with Edito. Somebody has managed to get it to work on his machine? No? No? You made the manipulation that I showed, changing the GPU number?
I can't access the service.
Ah. Shiva?
Do you see this as consumption?
Okay, any question at this step, or maybe we can switch to the next modality for running the data challenge? So we run the data challenge as we saw locally using the Python scripts and using the Editor Data Lab platform, and now we'll try using the Docker images. So as I said before, if you already had Docker desktop installed, you can download the Docker image using this command. If you copy and paste it on a terminal, and this command will also, once the image has downloaded, finished the download, it will run it, and you will have a pre-configured system running on your machine that will be used for easily running the data challenge, the benchmark. So I have already downloaded the Docker image. So the service is now running on the background on my system. And in the logs, you will see that it gave several links, and you can use this one starting with 127. You just copy it, and if you paste this on a browser, you will access the system that is running. It's the same interface that we saw here. It's a Jupyter Lab, same as what we got here in Editor. So we'll go the same steps that we have done on Editor. If we got a notebook, we'll run it, but we don't have a notebook yet. So let's go to the terminal and run the Python script as before. And here we have the same minimalist system, and if we go to the root folder, a directory will appear with the same name as on the Editor platform. We'll got directory named DC1 output, and the results will be stored on it. So we'll wait now the system to run, and it will show the results at the end of the process. Unfortunately, this will take more time than on Edito platform because it's running locally on the machine and it's using the connection, internet connection here in the room, so it'll be slow. A reminder about the speed. As we said this morning, we got in this configuration file these parameters about parallelism. And depending on the machine that you are running your benchmark on, you can improve the speed by using more workers in parallel. So here we are running on our machine, so we don't push this too much, taking into account the potential of the machine. But if you are maybe say running on a cluster or something like that, you can push much more workers on it and get faster result. Okay, evaluation has finished, and as we saw on Edito platform, we can find the result file here in the same path that before. So here is the JSON file with the metrics computed on each of the evaluation dataset that we configured. So we are done with demonstrating the tool itself. Now that we got this results file, what to do with it in order to get a better visualization of the results. And we go for the next step, which is to create a leaderboard. And for this purpose, we need the other repository, this library named DC leaderboard, that we will download using the link that you can find in the web page of the workshop. Let's clone the repository. Get into the main directory of it. And the next step will be to install an environment that with all the dependencies needed by this library. So there is a command that will create the environment for you. Just copy and paste. Yeah. We have to get in the this directory, this one, DC leaderboard, not at the root directory. We have to go to this folder before and then run. Why? No, I have to get out of this because I activated the and Conda environment. Here we have to get out of and go from the main terminal. So we run here this command to install the environment, the Conda environment. Okay, the Conda environment is installed. You can optionally check if it's working, but we don't go here. And next steps, in order to see our results in the leaderboard, is to copy the file that we have generated using the benchmark. To copy this in the same if I go here in this repository and in this leaderboard directory, you will see a directory named results, and you just have to copy your model here. The file, you copy it here. So this process is still manual, but as we said this morning, we will automatize all of this in order to get directly the leaderboard web page at the end of the process of running the benchmark. But for now, we are still in a manual configuration. So if I already have a sample of results here, named results.net. with same format of file that we generated with this. And to compare it to other systems, I will just remove these samples, and I will show you how to generate fake model results using this file in order to have something to compare to, because we just have one system now, and it will we won't see all the functionalities of this DC leaderboard library. We're using just one system. So the way to go is to open the terminal, and here you have the commands that will generate fake results. So we will generate fake results for two fake models just using the noise that we will inject in the results generated by GLONet on this subsample of the data challenge. So I just copy these commands here. And now you will see that we have two other files with results for these noisy models. And with these three files, we'll now generate a leaderboard using the command that you see here. So when we will have the complete leaderboard with several pages, you have a command to compile all the website. But now we'll just generate the tables with the compare the results with the command with the make file that is inside the library. So copy and paste this command and put it in the terminal, and this way we will get the leaderboard. Okay. So the HTML file with the leaderboard has been generated, and it will appear here in this leaderboard and site, the site directory. You have all the files for showing a website, and we are interested by this file, leaderboard.html, and we'll open it to see what has been generated. So this one is a leaderboard for the data challenge 2. So we have not only surface variables, but also depth values for each of the oceanic variables that we are evaluating on. And for each of the reference data sets that we listed in the configuration of our data challenge, we will see also for each of the metrics defined for each data challenge, we'll see a table with all the systems that we got results for. So all the each time we evaluate a new system, and the file resulting from the running the benchmark will be put here in the same folder. So each time we got a system, we got one more file, and so we'll see the same number of rows that we have models evaluated. So it is declined by lead days. Here we have forecast, 10-day forecast, but we just sample the these lead days in order to fit inside the table. And we group the, for example, salinity metrics computed at sampled levels of depth separated here in the table. And you can see that the first system, which is our baseline here, GLONet, is the reference for the color code that is shown here. So there is at the bottom of the page, you can see this map of the temperatures. It's the color. If it's red, it's it's worse, and blue is better. And the more darker is the color, the more difference between the evaluated model and the baseline. So and we got these tables for all our evaluated variables and all the reference data sets and all the metrics that we define in the configuration file. So there is all of this is can be parameterized in the config files that we showed this morning. So we got this leaderboard, and for now, well, we have separate tables for each of the references, even if they evaluate the same variables. But as I said this morning, we'll extend this the functionalities of this library to show average results for all the sources for the same metrics and variable, or the user can select also the source to see separate metrics for each of these sources. And this is the final result that we generate at the end of benchmarking our the models that are evaluated. And I showed, I think, all of the software. We demonstrated the software that we implemented. If you have any question about these benchmarks, you can ask, and your question are welcome. Yes.
Some of us got launching I think it's because of the feeding program.
Did you manage to? When did you create your account? Did you fill the form to get resources? Today or? Don't know why. Did you change the number of GPUs needed for also? So this is something wrong in the editor that we don't control from our side. It's still in development.
Yeah, just for people to know, the reason we ask for your accounts is because Editor has to validate some of the accounts to be able to allocate resources for you. So maybe something went wrong in that process in the validation. I think we sent every single thing that was sent up until a few days before the actual workshop.
No, for those who has answered the because we asked for your accounts to so that they validate the resource allocation for editor accounts. But maybe something went wrong in their side about the resources available, or I don't know. Yes.
I have another question. So I was able to build this page with a comparison, but with the files from Data Challenge 1. And it looks different, but it still says Data Challenge 2 leaderboard.
Yeah, because we still have only one. It's not customizable now. It's we just have one repo and one page. But when we go further the development of the data challenges, we'll put a link inside the repo of each data challenge to generate custom page for each one of them. Okay. So this is normal at the time, because this is just a sample. We didn't finish the to link, as I said. the generation of this leaderboard will be automatized at when we finish developing the data challenges. But for now, we're just manual, and we generate the same page for, we didn't customize the text. So it's just, this is a matter of customize the page for each of the data challenges. That's all. But if the tables are correct, is it the case for you? The tables that were generated?
Yeah, they're a little bit different. Like they have only one column.
Yeah, because it's because here I ran a test with forecast for 10 days, and it takes only odd numbers of lead days. So you got more here because the test that we made now is minimalist because of resources matter. So you just have the lead day 1, not the 2 because the second one because it's selecting the subset of.
Okay, yeah, thank you.
This is also something to customize by then. But now the policy that we put in this library is in order to group all the a maximum of results in the same table is to take also only odd numbers of lead days. This is why you get only one column.
Okay.
That's it.
Yeah, thanks.
You're welcome. Yeah, if you don't have any other questions on this topic, we can switch to another presentation.
Yeah. I'm just going to get closer to the mic so people can hear me properly. So, tu peux arrêter le partage? So hopefully you can see my screen there. So what I wanted to tell you about was some specificities of data challenge 3, especially regarding the config file, since this is one of the only data challenges that use this polar coordinate for most of its data. There's still some things that are not yet fully polished, which may seem a bit weird if you're just trying to run the data challenge without some previous knowledge. So just in case you want to use this tool right now to test some of your models, I will give you just a quick rundown of things to look out for and how you can actually make that work in your case. So here I just cloned the... I am not sharing my screen?
No.
Tu peux mettre le OceaniX sur ce micro-là. Ouais. There, I don't think you can see much. Let me just figure out how to get the font size a bit bigger. Comment tu sais comment faire?
Contrôle plus. Au hasard. Non.
Voilà.
Si. Good.
Love, you managed to see what's going on my screen there in the room? Or is it a bit small still? I see people forcing their eyes, so I'm just going to keep... So, are we okay there?
Ça. À la gauche.
If we switch the lights off, how good light mode?
Yeah, maybe. Just changes. It's that better. Okay, good. I just cloned the repo and hopped on the config file to just change a few parameters before actually running the evaluation. So by default, just because that's how we configured it in the repo, we are ready to make seasonal forecast, would take quite a while. So what if we just want to make short-term forecasts, like in the case of this demo, because we don't want to spend half an hour just waiting for the thing to run. So one of the things we have to change is the amount of days that our forecast covers. So in this case, we're just going to do one forecast per year, which is not very realistic for short term, but oh well, for 5 days. So we changed this number here, which was originally 181 for a seasonal forecast. We just changed it to 5, and we also have to look out for the end time. So we also changed that date, making sure not to filter too much, because what I saw that happened to some of you was that if you change your end time to not cover the whole forecast period, it will just filter it out, and you will end up evaluating on 0 forecasts, which will say ended successfully, but actually you did not evaluate anything. So really make sure to keep the end time at the right date. And another thing that might happen is that if your computer has less memory than mine, for example, you may run out of memory if the number of workers or their memory limit is not correctly set. From some talks we had with Emmanuel, it can happen that if you run a very long evaluation over a very long period, with a memory limit that's too low, your workers may run out of memory. So that's something to watch out for if your evaluation does not work. It may just be a problem that the data you're trying to evaluate just doesn't fit into memory, even if you cut it into tiny pieces like we do with desk and everything. So once this is done, the filtering here by region, we're not going to touch that since we're evaluating over the whole Arctic. But what I really wanted to show you was how you would add your own model to be evaluated in the case of this data challenge, which is also the same as the other ones. So this is not just for the people who want to evaluate ice models. So in the sources part, we have all the observation data that we're going to use. In this case, we're only using AMSR2 data for sea ice concentration. This is all stored in Wasabi, which is an S3 storage solution, a private one that we have while waiting for access to DataArmor. But once that's done, we will also have a configuration that will retrieve the data from DataArmor directly. But yeah, this is just the reference data. What we're interested in is in putting our own model in the config file. So our models are not going to be directly in the evaluation scripts at any point. What we're going to actually give as input to the evaluation is going to be the inference from our models. So we would, for example, make predictions for the whole year 2020, and then we would add that as a data set that we're going to compare against the observations. So in this case, we're using Topaz, which is a reanalysis product, if I'm not mistaken, as if it was a participant that's trying to evaluate their model against. So okay. So yeah, let's imagine Topaz is our model that we want to evaluate. So we use our model to create these predictions, and then these predictions are going to be stored somewhere. So we just add those predictions as we would any other data set that we're going to use for evaluation. The only difference is that we set it as not an observation data set, since it's actually predictions. But then you could pretty much copy the config from the other data sets. Just we set the metrics that we want to evaluate on, for example, root mean square error. In this case, we have Topaz also in the same S3 bucket, but if you have it locally, you could also configure this to go search in your local hard drive or whatever. And And then we just have to specify a file pattern, just in case our predictions are not in the same file. So this provides quite a bit of flexibility because you don't have to concentrate everything into a single data set. Sometimes your data set might just be too huge, like in the case of GlowNet, for example, to actually do this. So it's very nice that we can just separate it into different files and actually do lazy loading. So we only load the files when we're actually going to use them. And then we can also filter the different variables. So in this case, I'm just choosing to get the sea ice concentration from Topaz to evaluate on, even though there are plenty of different sea ice variables that are present in this reanalysis. So I'm just keeping the y and x variables, just so my data set has coordinates. The time, of course, just to know which observations correspond to which predictions in my data set, and also the name of the variable. You will notice that CS concentration has a different name here as in AMSR2. This is not a problem. This is managed internally. We have a huge catalog of different variable names and what they correspond to in standard names. If you do find any problems with this, you can either raise an issue in the DC Tools GitHub, so we can update those catalogs for some of the data sets we may have forgotten to consider. So with that out of the way, let me show you what the evaluation looks like. I actually ran it.
To be complete, if you want to configure all the these data sets, you have to go in the main script evaluation.py. You see, where you will declare what is the data set that is the reference, and what is the data set that will be used to that will be evaluated. We will document all of this and put the documentation on each data challenge.
Yeah,
by the
we are aware that this is a lot of information, but anyway, I can show that later. So here I actually ran the evaluation beforehand because the network here is quite bad. So I just wanted to make sure that I wouldn't make you wait for too long while the whole thing loads. So what we do when we run the evaluation is pretty much just run this script here and specify a place to put the logs in case anything goes wrong, or that everything goes right, hopefully. And also a data directory. We're going to actually build what's called a catalog. What we call a catalog is just a list of different files that we have available and their metadata. So that will allow us to, once we know what our available data is, just go look for the specific files directly without having to actually list through the whole directory and check that those data actually exist. So once we launch that, it's just going to create the directories, spawn different desk workers, because we really focus on the parallelism part of the whole thing. And here you will see it realizes there's no catalog file that's been created. So it's just going to create it the first time we run this, and it's going to open absolutely everything that we have in the S3 bucket that fits the patterns that we gave it. So in this case, it's just the name of the AMSR2 file plus the date plus the version. Anything that fits this description is just going to open. So it will give you a lot of debug messages that we hope to change at some point with some kind of parameter. And once it has opened all of them, it will make a list of all that are available. And yeah, then it will just filter the different variables that are necessary. So in this case, it's just Z, time, X, and Y. And it will filter also by time later. In this case, we also put in the config files 2 data sets that were not declared as being part of the evaluation. So it's going to automatically skip them. If you want to delete those warnings, you can just just comment them out of the config file. But this will also warn you if you have forgotten to declare your model as part of the of the evaluation. So if you see that your model is skipped here, it's just that you need to declare it as being one of the models that is going to be evaluated, which we can show just after. So once it has set up answer 2, IABP, and MODIS, it's just going to go for Topaz as if it's any other data set. So here it's just going to do exactly the same thing, look through the S3 bucket and pick any file that has already been, that fits the file pattern. And what's interesting is that it's not going to open them, actually. It's just going to lazy load them, meaning it just gets the metadata, but it's not actually downloading the actual values of every single variable. This allows us to open this very, very quickly. As you can see, it just takes like some milliseconds between different files. So if we scroll all the way down, eventually we're going to reach the end of the catalog creation, and now we're actually in the evaluation part. So we're going to first filter the different data sets by date. So it's going to make sure that we only open the files that we actually want to open that correspond to our forecast. And then it's just going to start the evaluation. So then again, it's going to look again for those files that correspond to that forecast, open them, and this time it's actually going to use the values inside. So before that, we had never actually loaded the values into memory, which leads to massive gains in performance. And since we're also parallelizing the whole thing over different workers, we have different lead times being run in parallel on different workers, which will show up a bit weirdly because they're not done exactly in the right order. That depends on how fast each worker treats their data. But yeah, each worker is going to pick a lead time to process, and then it's actually going to open the other data set that we want. We want the reference data set and we want our predictions. So when it opens the predictions, in the case of Topaz, we do not have latitude and longitude. This is not a problem. This is just that the DC Tools library was originally tested on Glorious data, which does have this latitude and longitude coordinates. So here we'll say that longitude is not present. You don't have to worry about that. We're going to remove this one very soon. If you do find any other warnings apart from this one, there might be a problem with either your data or the code itself. So we would very much like to get your feedback if that's the case. So yeah, once it does that, it's just going to process each variable sequentially. Here we only have sea ice concentration and calculate a metric from that, which it will then just write in the result file as Kamel showed before. So if we go into our results file, you will see that we have calculated the metric for each lead time for the sea ice concentration and eventually other variables for model Topaz with reference answer 2. So here we have an error of around 11% on the sea ice concentration over the whole Arctic. I would be very interested in getting feedback from the scientific team of the third DC to know if this is acceptable or something that we would expect to have. Just as a quick note, if you see errors of around 50%, it's either that your model is incredibly bad, or maybe that you are considering sea ice concentrations between the range 0 and 1, while the reference data set uses concentrations between 0 and 100%. So if you're predicting between 0 and 1 all the time, it's as if you're predicting no ice over the Arctic, and that may lead to artificially bad results. So I think those were all the quick notes I want to give you on this DC in particular. So if you have any questions, I would be happy to try to answer them. No questions in the room, and I'm guessing online is going to be more or less the same thing.
No question.
Okay. In which case, I think I can just go straight ahead into the XK presentation that Jean-Olivier was very interested by. So hope you guys are seeing my screen there. Yeah. So now we switch very radically what we're talking about, because here we're talking specifically about a tool that we developed for the 5th data challenge, which concentrates on marine biodiversity. And so I developed this tool called Xscape, which the short description is it's a Python library for recovering the seascape around the set of geographical points based on X-ray. So first, the question that may arise in some of you is, what exactly is a seascape? So you might have seen this picture around 3 trillion times over the past few days. So a seascape is basically an n-dimensional cube centered in a measurement, and measurements usually have a position on the Earth and a time when they were taken. So the seascape might just incorporate the water column at a certain place. It might just be a whole area centered in a place. And it may also include time, for example, the past and present of that area, or even the future, and different channels. So we might have different sources of information about the environment of that measurement. And the idea of the 5th data challenge is to use this information to predict fish and plankton abundances. This problem is something that people in the marine biology space, when they're trying to do machine learning, they face this quite often from our discussions with the team. But yeah, it's something that happens very often, that they just want to they have in situ measurements of fish abundance, because that's the only way you can actually measure them. And they want to know what happens when the sea state around is different. The problem is that most of the tools that exist for that were developed by people who were trying to do something else, and they just wanted to get this problem done. So there's not a lot of optimization going on here. The only tool that actually focuses on solving this very common problem was the GeoEnrich library. Here you can see an example that I took from their repo, where they just have a massive data set of 10 or 30,000 different surveys, and they cut a square of the bathymetry around each one of them, which they can then use to make predictions about the different fish abundances. But this effort that people are making multiple times is just basically wasted, because other people cannot use those ad hoc tools for their purposes. So what I attempted to do with Xscape is to have a simple and accessible tool that is very easy to extend and to integrate into your project. So whenever you need to just cut a square around your points, you will just think of Xscape, and it will just do what you need very quickly and simply, without being a pain to install and to make run with the rest of your code base. So I kind of got inspired by the Unix philosophy, just doing this one thing very well and making it very, very optimized, and making it simple to integrate with other packages, just so we would avoid the following situation that I feel you may have seen in many other code communities, where there's 7 different solutions to do something, but none works exactly as you want. So people just developed a new one, and so on and so on, and you end up with 20 libraries that all basically do the same thing, just slightly differently. So now I need to justify, like, why are we developing Xscape then, if there's already a library that does it? And the main reason is that previous solutions are not based on X-ray, which is the tool that we use for basically all of the processing in our data challenges, and that I feel like almost everyone uses when they're dealing with model output data or any type of geophysical data. Additionally, the other solutions were quite slow, so it took hours to process just a couple of thousands of points, which is good if you just want to process one data set and be done with it. But when you're dealing with a benchmark where you may be doing that for your own model predictions, you really want it to be as fast as you can. And also there's one problem which other solutions don't solve as well as I would like, which is the size of the different seascapes. Because when you have a grid in latitude and longitude, all the pixels are not the same area in real life. And so the way GeoEnrich solves that is quite smart, actually. They just change the amount of pixels that they take depending on what latitude they're at. The problem with that is that usually machine learning architectures are not that robust to different sized patches. So we really needed something that built patches of the same size at every single latitude. All that made other solutions difficult to integrate, even though they may be useful for non-programmatic applications. So I know GeoEnrich has a website where you can just upload your data and it will give you the NumPy array that comes out. But yeah, we thought they were not sufficient for our purposes, but we definitely stole some code from them. So we took some inspiration from them. And I really do want to thank Gaëtan Morin and Enza Labordette. Gaëtan Morin is actually the developer of GeoEnrich, which had a couple of meetings with us where he explained the problems that he faced. So big thanks to him and to Enza for sharing their code with us. So Xscape, to give you a quick overview, can handle large number of seascapes way faster than the alternatives. So whereas other alternatives were like took 2 or 3 hours to process a couple thousands of points, for example, I will show you just after that we can process 1,000 points in just 30 minutes, and the scaling is quite good. So if we do 10,000 points, it doesn't take much longer than that. It also avoids duplicate seascapes to save memory. What happens sometimes is that if we have two seascapes that are very, very close together, 2 points that are very close together, sorry, the seascape around them is basically going to be the same. And if we have a lot of points and we're cloning seascapes left and right, we're just using a lot of memory that we don't need. So Xscape uses quite ingenious, if I'm allowed to say that, indexing method that allows us to recover seascapes quickly without having to duplicate them for each of the seascape. Additionally, there's some helper functions to test Xscape that you might find interesting if you just want to request some data for a quick script or whatever. And also integration with Desk allows us to do lazy loading, so not loading huge data sets until we absolutely need the values for the computation, which makes dealing with things like Glorious, which is huge, very, very quick. And so now I just wanted to do a quick demo. Like I have prepared 2 notebooks to show you what Xscape is capable of. So here we're just going to import Xscape, and hopefully it's going to work. Yeah. And just as some testing functions, I created just a point generation one where it will generate a data frame in a set of points with a certain latitude and longitude. You will see that this is not very realistic because some of the points fall on land where we don't actually have data. But this doesn't actually matter because Xscape will be able to tell that a point is in a place with no data. It will just not take it into consideration. And if you're trying to access the seascape for that point, it will tell you that there's no seascape that corresponds to that. So there will hopefully not be any weird errors that you encounter while using it. Then once we have these points, we just have to define what we want to get around them. So here I just defined a seascape size of 3, so 3 degrees around each of the points. Start and end time date for the background data that we're going to use. We're going to use the temperature variable of Glorious for this period here. We just give it the points that we want to get the seascape for and the size. And here I'm just selecting one time snapshot and one depth snapshot, but Xscape is able to handle the whole water column if you so wish, and even seascapes that have a time dimension, so you can get the past and the future of the ocean state around your measurement. So here, I guess I'm not going to run this right now because the plot actually is the part that takes the longest of the whole notebook. But here we're just making the requests in a way that only covers the area that we need for the seascapes. So we're not getting the whole of Chloris here. It will actually choose the smallest envelope possible so that we cover the whole area of the points without needing to DDoS the server by requesting it a million times for each of the data points. And here we reach the main part of the Xscape library. It's actually two functions. It's just create an Xscape data array. So once we run this, this actually takes around a minute for the 100 points that we have here. And in this case, we're not actually converting to a kilometric grid. We're actually just taking a certain amount of our seascapes in this case are going to be in degrees. So once this runs, we get a data array like this, which has a seascape index dimension. So one seascape for each of our dots. I guess they were not exactly on the same pixel when we created them. We have a seascape longitude and seascape latitude. And in the variables, we actually have different coordinates. We have, can you guys actually see that here? Not really. So we will have the center longitude and center latitude of each seascape. So we know what each seascape corresponds to. We have a relative longitude and latitude, which is as if we just set the origin of the coordinate system at the center of the seascape. So we know that we know what each pixel, where each pixel is located with relation to the center of the seascape. And we also have the actual latitude of each pixel. So for each seascape, since the origins are different, the relative and latitudes are going to be the same, but their actual latitudes on the Earth are going to be different. So that might be interesting if you're trying to predict some kind of property in the water column, for example. It will change depending on what latitude you're at or the different regions on Earth. So this is useful information that it's good to have. And yeah. And so when we actually plot each seascape, this actually goes quite fast. And we get something like this, which is pretty much what we were hoping to get which is pretty much what we saw in the presentation when I showed you the other image that was obtained with GeoEnrich. But now I think the most interesting part about Xscape is the fact that it can automatically convert seascapes into kilometric grids centered on your point. So that means that for each measurement, you do actually get patches that are exactly the same size in real life, which is very good to get physical structures. And if you're training, for example, a convolutional neural network, it will actually learn that a pixel is this scale, and it will not have to deal also with deformations due to latitude, which is a problem that, according to the scientific team of DC5, people had encountered quite often. So here, the way we do it is basically the same. I'm just not plotting much just to make it quick. We define 1,000 points in this case. And same thing, just in the North Atlantic, 1,000 points. And here we have the data frame that comes out. As long as you have something like this and optionally a time column, you can use Xscape. This is all you need to actually get the seascapes around them. So here, same thing, I'm just gonna get 2 degrees around every single point just to make sure that we have a good margin around each of them. But here, instead of just building a data array from that, we're actually going to define a seascape extent in kilometers. So we're going to take a cube, a square that's 100 kilometers inside around each measurement, and we're going to interpolate so that the grid size is 1. We could change that to anything we want as long as the grid size is smaller than the extent, which will allow us to adapt the resolution of our patches to whatever kind of model we're trying to train with this. So we just give these parameters to the function, and you will see that we can also get a time range for the seascape that I'm not going to do now, which will just give us also a snapshot in time of the seascape. So it's past and future. Here we're taking 60 hours before and after, and just getting every single snapshot in the background field that fits that time range. We can optionally just get the water column, so dealing with the depth dimension as well. And this compute result option defaults to true, which is related to Dask, because Dask will not compute the actual seascapes until it actually needs to use them for some other computation. Sometimes if you put this to false, it will go faster. Sometimes it will go faster if you just compute it in one go and then compute on that. That depends on your application, but it's very case by case. So there's no global recommendation. So to give you an idea, this thing here where we have to interpolate 1,000 grids in this very, like in changing reference frames, only took 36 minutes, whereas previous solutions took around 2 hours to do something similar. So this is what we get when it goes out. So you will see that the seascape longitude and latitude coordinates were actually changed for seascape Y and X, as we would expect. And the fields here, I haven't plotted them, but they're just the interpolations at a very local level of the high definition, the high resolution glorious background field of the temperature. Here we just have some attributes that are internal to Xscape that will allow us to actually index very quickly our seascapes. And for example, here, with this accessor function, we can very quickly just go from the 10th point in our data frame to the seascape that corresponds to it, which is just a 100 by 100 kilometers square round. So that is Xscape. I hope that if it's interesting for your work, that you will use it, and do not hesitate to take a look at the GitHub and give any feedback you may have, or just propose new additions to the library. That's why I developed. I just wanted to be a very open thing and collaborative thing for the community. So yeah, thank you for your attention, and I'm gonna take any questions you may have. Do we have any questions in the room?
Yeah, a question from Jean-Olivier.
Yes, surprisingly. So I've brought some backup also. So Leo here needs to do a lot of this. So hopefully we get to use this very quickly. If I understand correctly, so first, thank you very much and congratulations on making it so quick. And if I understand correctly, part of what makes it quick is that you fetch a large extent first and then you cut locally, basically.
Yeah.
Well, as I understand it, GeoEnrich fetches for every crop, basically.
Actually, that's one thing that GeoEnrich does quite well.
It does this already.
Just
okay.
Gets it once and then avoids DDoSing the DFRANAS server, for example.
Okay, good. But what if we have points that cover the whole Earth? It would just fetch everything, so we would need to cut them into pieces before, I guess.
Yeah, in that case, you will actually fetch everything, but what it's actually fetching before I actually do the plot, which is why it takes so long. When you fetch the whole Earth, what you're actually fetching is just the metadata. So you're not actually loading the values for every point on Earth, which would be huge. It's just seeing what it has available, and when it actually goes to do the interpolation, it's there that it loads just the necessary values. So that's what makes Xscape quicker and less memory intensive than GeoEnrich.
Okay, and so it loads the necessary values, which means the ones that are covered by the square that you defined.
Basically, yeah.
Okay, great. I mean, a small technical question, but when you say 3 degrees, it's 3 degrees on either side, or it's 3 degrees total?
Total.
Okay.
Yep.
And then, yeah, a few other questions. So I see that there's basically a specific function to get the GLORIS data. I'm guessing that there's similar functions for other data sources. So how does it work? I mean, there's functions for every single variable, I mean, every single data set in CMEMS, or?
Yeah, I actually thought of building a function that just gets any variable from Siemens or whatever. But then I realized it would just be adding complexity to the CMEMS library. So what I envision people will do with Xscape is to just load their X-array background however they want, either from an S3 bucket through the API, and only then use Xscape to actually cut it up into Cscapes. What I'm doing here with GLORIS is just a little helper function to make it a bit more understandable what we're doing, because if I do use the CMEMS API, it will be much more flexible and much more useful for most people. But I think it would just be confusing, and for the purposes of testing or showing people in the demo what Xscape actually does.
Okay, so there's a generic function getting a data set on CMEMS and then cutting it.
Yeah. So
okay.
I would recommend that people who want to use Xscape actually just load their data before, however they want, for example, using the CMEMS API, and then only then use Xscape, instead of trying to build a library that loads everything and where we have to take care of every single different data source.
Oh, okay. So the initial loading of the, let's say the big array before cutting, this we do externally, and then Xscape is used to cut the pieces. Is that right?
Exactly.
Okay. Yeah. And so we can probably get inspired by what is in the get GLORIS var to do this.
Totally, yeah.
For other variables. Okay. And so underlying get GLORIS var, it's what it's calling Copernicus Marine. So it works only for this, or it would work for any collection of netcdf files, for example.
I'm not sure I heard the question properly. Could you repeat it?
So the initial fetching of data that is done here in get GLORIS var, does it rely specifically on the Copernicus Marine library? So it means that it's specifically to get data from Copernicus, or is it, I mean, would it work with any netcdf file or with data provided by NASA, for example?
Okay, yeah. This particular function uses the CMEMS library behind it, so if you want to modify it, it will only still open CMEMS files. But then there's just X-array point open, which will open any netcdf file. And after that, it's basically the same thing. It's just a data array in memory that you have open. So I have tested this with some other data of the World Ocean Atlas, some other netcdf files, and it also works very well. So the opening part is not managed by Xscape at all. It's just managed by X-array, which has a lot more development resources to actually make that work with very different sources like GeoTIFF images and rasters and all kinds of images. So yeah.
Okay, so yeah, basically anything that you can load is in an X-array lazily, so without loading the whole data, then Xscape takes care of loading just the grid that we need and cutting them.
Yeah, and I'm not aware of any particular type of data that you cannot load lazily. So
Okay.
X-array can actually do that for local netcdf files or GeoTIFF, I think. So it shouldn't cause a problem.
And so I have a question about the interpolation, but I'll just go see in the code. And maybe last question that might be relevant for physical oceanography models. So I understand there's some cleverness in the way that you collect either in degrees or in— but for the depths, for the depth coordinates, a lot of the model output is on sigma layers, so the depths change depending on which point you are in. And I was wondering whether you considered this or knew about this, and whether it could be a future development to regrid over like a meter coordinate in depth, also based on the sigma coordinates.
Yeah, that is something I have thought about quite a bit. Right now, in its current state, X-ray just Xscape, just interpolates on the horizontal dimension, and it keeps the original depth coordinates how they are. But it would certainly be interesting, and it's something that I have in the future development plans to add some kind of interpolation in the depth coordinate, especially since there's a lot of different vertical coordinate systems that are used, and usually the vertical interpolation is something that everyone has to do when they want to train a model for prediction, for example. So yeah, that's certainly something we consider, but we would very much welcome any expertise someone else might have for developing those parts of Xscape.
Okay, well, thank you very much again, and we'll probably try to use it very quickly, so you hopefully you won't get any questions, but maybe you will get some questions from us.
If I wrote the documentation properly, I might get less questions, but I'm always open to answer them if you want.
Yes, of course. Bye. Thanks.
Thank you.
Any other question on Xscape? No. For those of you that have issues with accessing on Edito platform, we got an answer from Edito team, and they say they have an issue with their cloud provider. So it's not even on the Edito side, or they cannot run the service now. So that's it.
Do we have anything else planned for today?
No, we are done with this demonstration session. So Ronan Fablé will close the workshop.
Okay. Non. Je pense qu'on peut passer en français là. Ça serait juste pour